In this video, I will show you how to find the first and second derivatives of the parametric curve. The parametric curves are formed by two equations, x equal x of t and y equal y of t. Remind that t can be expressed in terms of x. I mean, if we do t here and apply the inverse function of x on both sides, and we got this. And then y also can be expressed on y, evaluating the inverse function of x respect to x. Now we're gonna apply the chain rule here to find the y dx. Now the y dx, but this is t, right? This is t. In this video, we will find the first and second derivative of the parametric curve. The parametric curve is formed by two equations, x equal x of t and y equal y of t. But if I apply the inverse function t also to the x, also if the inverse function of x applied to x, therefore y equals y of t, which is the inverse function respect to x, and this is t. Now we're gonna apply the chain rule to find the dy dx. Now the dy dx is here. It is the derivative of the outside function, which is the derivative of the y respect to t, times the derivative of t respect to x. The derivative of t respect to x. But this is the derivative is a reciprocal of the derivative of the original function, which is 1 over the derivative of x respect to t, and that's what I have here. And the final answer is going to be this. The first derivative of the parametric curve is dy dx divided by dy respect to t divided by dx the derivative of x respect to t. And then we have the first derivative here. For the second derivative, we will apply the quotient rule and the chain rule at the same time. Now, the derivative of the top, which is the second derivative of y respect to t twice, times the derivative of the inside, which is the derivative of dt respect to x, which gives me this part here, times the bottom without doing anything, minus now I will do the derivative of dx, I mean the second derivative of x respect to t twice, times, of course, the chain rule again, because t is dependent of x, times the top, which is the y of dt, without doing anything, and everything at the bottom we square the bottom by the quotient rule. Now the second derivative final answer, you do the algebra, you arrange the fraction, you find common denominators, and the final answer is this. And let me delete everything, and you can have a clear picture of how it looks like. Everything clear. You only have to see if that makes sense, and you have the clear picture here. Delete this. Okay, you can apply this formula directly to when you want to find the second derivative, you can apply this formula, and when you try to find the first derivative, you can apply this formula, and this is for the second derivative. Thank you.